Assalamualaikum warahmatullahi wabarakatuh, and good day to my panels, Dr. Mutafiq bin Taib and Technology Sheikh Ismail Fairuz bin Sheikh Zakaria, for spending their time to listen to my bachelor degree project presentation. I would like to thanks to my supervisor, Technologist Muhammad Noor bin Hashim, and my co-supervisor, Dr. Muhammad Khairi bin Muhammad Noor, for giving me a golden opportunity to do this project. And thank you for giving me the support, the guidance, and knowledge in finishing this report. First of all, I would like to introduce myself, Mohammad Azimin bin Abdul Aziz. I'm 25 years old. I came from Miri Sarawak, and now I'm a third year student from Bachelor of Mechanical Engineering Technologies, that is Maintenance Technologies with Honors, BMMM. Today I would like to present about my project entitled Development of Structure of Small Scale ROV for Educational Purposes, where I'm being given the part for Service Model. So this is the content. The first one will be the introductions, the second one will be the literature review, the third one will be the methodology, the fourth one will be the result and the discussion, and the fifth one will be the reference. For the introductions, ROV has been used and have increased in uses following their usefulness in getting job done. Many of the vehicles being used for underwater activities in many different genera of companies such as oil and gas, installation, structure, pipeline, and surveillance of the underwater surrounding. Remotely operated vehicles are known as ROV, which are operated by a crew either aboard or floating vessel on proximate land. These vehicles are used for research observation of underwater activities. ROVs are unoccupied, highly useful, and can be operated by one person, where they can be safe from any dangerous surrounding. ROV is imparted with cameras and recording data. ROVs are built in many different ways, either from size or shape. Their main features is still act as monitoring device towards the human to help understand better the aquatic life. ROVs are equipped with buoyancy units that provide sufficient life force and vehicle stability, and a number of thrusters or impellers provide manipulation of movement of the whole unit. Introductions. Remotely operated vehicles ROV is a tether robot often employed for underwater operation. ROV is performed through a remote control while the pilot who is in control is far away from the scene. For example, on onshore or floating vessels, below is the description of our basic remotely operated vehicles, which consists of control, navigation and control system, thruster, light, camera, body structure, service model, power model, and manipulator arm. So for the objective of this project is to design and develop a small-scale ROV for educational purposes. Number 2 is to fabricate a watertight body structure for ROV to store electronic component. Number 3 is to test the small-scale ROV creations. Now for the scope of research, the electronic component designed to be waterproof. The maneuverability of ROV consists of surge, heave, and different movement by using 4 horizontal thruster and 1 vertical thruster. Number 3 is the nozzle of the thruster is propeller efficient. Number 4 is consists of grabber, which can grab an object underwater. Number 5 is able to fabricate the structure part of ROV using existing facility at UTM workshops such as 3D printing and laser cutting. So this is the problem statement. Is to creating the small ROV design which is suitable for body and density at the water level, creating a mechanism which can be waterproof and can be remotely be in control of the movement, choosing the right material to use which is suitable for watery environment, and also waterproofing the materials. An unstable ROV will turn considerably more as less force can be used to do the work required. So the needs for a stable ROV. Finding the mechanism to move the ROV, which either motor or propellers, which in combination called thruster, deciding which size best fits for the motor and the propeller design, and choosing the right design and carefully understand the mechanism of ROV. For the literature review, the history, the first fully ROV made by Dmitry Rubikov in 1953. However, it is not until the United States Navy took an interest in ROVs technology in the year 1961, the US Navy created the cable control underwater research vehicle known as CURVE. Even though CURVE was used in sunken torpedoes, it paved the way for a brand new, which is the implementation of deep sea exploration. Following the success of CURVE, then US Navy have made investment in ROV industry. ROVs are mobile robot designed for working environment underwater, came in different size from small to large, and each of it a use of environment to observe. ROV is a camera mounted in waterproof enclosure where it uses a thruster to move around, which being attached to a tether or as being termed cables to the surface, which is used to transmit data to the pilot to record the finding of the data, either in taking photo or taking a video of the water environment. ROV's equipment with light and camera attached to their inside of a system body parts and have a mechanical arm to lift or grab object. Literature review. Basic component. The main component of ROV is mostly the essential part where the mechanism work and how the position take place, which contain of frame, camera, ballast weight, tether, thruster, and lamps. So this is the basic component for the ROV, which is the frame. The frame design is to ensure that it can be inserted with all the components and be attached to the design. The frame must come firm to be support the equipment weight and also have the height in the stride to carry all the materials that are going to be assembled. For the second component, camera, the camera will be function as it able to monitor the surrounding. In addition, the camera can be used as memory data that can record and report back what has been seen throughout the diving period. For the ballast weight, it is essential to control the balancing of buoyancy of the ROV. The amount of the weight and air must be appropriate to be controlled so that the center of the gravity of the ROV is at the right position and doesn't cause any turbulence when inserted into diving state. Tether function as a medium that carry instructed movement done by the controller at the water surface or the pilot who is in charge of controlling the rove. In electrical system, the signal transmission is one of the two categories which are parallel and serial data flow. Another element need to be taken in consideration what type of thruster are perfect to be used and the propeller in how the design and fitted for our mini ROV design. All of these details need to be taken in consideration following all the material uses that will change and set upon detail of the vehicles when inserted into watery surrounding. Literature review, power transmission. The power transmission is usually being obtained from on power source requirement where the ROV is being driven by it. Moreover, the most important is to start from the end of the power source and work backwards towards the side of the ROV power source. Preceding that is important to have the power supply towards working the ROV mechanism. It is also important to mention there is a sufficient power for each individual component. The power source. The type of voltage on the system is based on the component that needed to be installed on the vehicles. DC power mostly the most uses in the ROV system due to its weight of the vehicles. The electrical component or board, lights, camera, and sensor are generally powered by using the energy source more to direct current. Meanwhile, alternate current power is used on large ROVs due to its longer transmission range that AC able to provide the amount of power that can be provided to support the performance component. Vehicle control for power system. The control system of vehicle is the most essential part that are commonly used to manage the various functions of the ROV system, including thrusters, sensor, lights, and more. The basic function of the control system is to change and transmit the operator input into commands that will be imitated as an action of the vehicles. 2. The execution of this project, which is the 3D printing. The process begins with a 3D model of the object. These objects are needed to create from a software such as AutoCAD, Design, CAD, Inventor software, and many more software that are able to create design and object following the measurement and the detailed process of material selections. And the second one will be the CNC laser cutting machine. It will be analyze the drawing design based on the drawing from the Inventor software. After analyze all the design, the machine tool will operate based on the coding instruct from the workstation. The cutting process will be based on the design that created. This is the methodology or the flow chart. We're going to start with the house of quality HOQ and then go to the morphological chart and then to the park method and then the proposed design, the fabrication process and testing. If it doesn't work out, we're gonna going back to the house of Q and go back to the house of Q morphological charts, park method, proposed design, fabrication process and then testing. And if it does work out, we'll be put on the data collection and analyze and it will be done. This is the assembled design for service model design. We have 4 parts, which is the first part is the housing, the electronic tray, the end cap, and the start cap. So from the assembled design, we have the housing. The housing consists of the part where the components are intact into and outer the service model region. This part is the most important where it combines all the components and the center place of the main source or the force or the energy uses. Electronic tray, this part of the component is imported to its functionality where it is where the electronic components such as wire are such intact into the service model. The electronic tray is where the energy will be inserted while protecting from the environment such as water, the vibration that will intake during the process of testing the ROV itself. The end cap. The end cap is the sealing part of the component where it protects the electronic tray from moving and dropping out of the housing. It consists of a thread on the end of the cap to seal up the housing from the back of the housing. The start cap. The part of the component is essential for rear view where it is a placement of the camera and the lenses to be able to see what the camera are seeing in the water region. This part is essential where it also acts as a seal for electronic tray, protecting from getting wet and causing it to be malfunctions. This is the 3D view design that have been assembled together for the service model. This is the HOQ or the house of quality for frame of small scale ROV. So here we have the house of quality for the frame scale of a small scale ROV. Here we have the importance rating. Number 1, 3, and 5. The 1 is low importance, 3 is moderate importance, and 5 is high importance. The frame of small scale ROV is on the product requirement, which is a small scale, lightweight, high mobility, withstand high pressure, easy to add on testable design. The present rating is based on the importance rating that have been stated. The engineering characteristic, and here we have the dimension, type of materials, hydrodynamic, high density, compatibility, and sample design. And then we're going to test out the importance score, the tip weight, and the importance rate. This is the characteristic of service model of the small scale ROV with options. So here are the characteristic of service model of the small scale ROV with options. Characteristic, which is the service model materials, dimension of service model, dimension of the housing, dimension of the electronic tray, dimension of the end cap, dimension of start cap. We have option 1, option 2, option 3, and option 4. And this is the criterion importance of weightage in service model using a puck method. So this is the criterion important of weightage in a service model using puck method. The criterion is service model material, service model design, dimension of housing, dimension of electronic tray, dimension of end cap, dimension of start cap. We have the total positive, total negative, then the final score of the weightage. For the expected result, expected that prototype of the mini ROV will be floating due to its materials that have been chosen, which is the nylon, where it's compact and light following its properties. Number 2 will be the ROV will be able to be assembled based on its individual parts, and also be transport the data to the laser cutting on the 3D printing machine to be extract the information of the size and the dimension of the prototype mini ROV to make it as whole and can be assembled freely. And we can also insert all the electricals and mechanicals components with the prototypes of mini ROV. Power module, where it's carry the motor and propeller able to move from side to side, forward and backwards. Be tested into the bucket full of water to see its movement and checking if there is any misconduct happen or the system does not work while under the pressure of the water level, and also be able to move forward following the instruction from the remote control, that we can assume that the project is a success. So this is the Gantt chart or the working schedule. For the finding of this research, here are the references. Now for the conclusion. In this PSM1, we've mainly focused on designing and gathering information regarding to create and fabricate a small-scale ROV later in the condition of PSM2. By using the necessary equipment and machine, the tools at UTEM will be able to fabricate the designated ROV and assemble all the parts that are being assigned by our supervisor, which is include the service model, the power model, the body frame, and the manipulator arm. We're hoping the design of each part will be fitting to each other. Before starting to fabricate them, we will try to assemble all the parts using Inventor 2020 features. When that's done, we'll be able to focusing on creating a power source system which we can apply to the ROV, and when that's done, our ROV will test it out in securely watery region. We hope that this project can be beneficial to the student, where they can learn from our ROV prototype, inspired with how amazed the technology is nowadays, and giving them insight how ROV works, basic component, and to replicate the ROV prototype and what does it do. Thank you for spending time with me, and Assalamualaikum.